For the homeostatic control system, and as all of you are familiar with the homeostasis, that it is a natural mechanism in the body which is to maintain the internal environment relatively constant. We can't say that our internal environment it can be set at absolute constant state, but we will say that our homeostatic control system it tries to maintain our internal environment relatively stable or relatively constant. So as all of you know that all the activities of the cells, whether they are activities are performed at the cellular level, at the tissue level, at the organ level, or even at the organism level, all of those activities they should be regulated, and they should also be integrated with each other. So integration is essential in the sense that if there is any fluctuation in the extracellular environment, all the organs of the body, they are the organ system of the body, they must coordinate or integrate with each other to cope with that change in the external environment. So and the body will respond to minimize that change. So homeostasis is a natural mechanism which is present in the body, and it tries to maintain the internal environment relatively stable. And why this homeostasis it is operative in the body? Because as all of you know that environment is constantly changing. The changes they are regularly the changes are there in the external environment. So to compensate those changes, our homeostatic control system it will produce a sort of regulatory response, and this regulatory response is performed by the homeostatic control system. For example, if we take the example of body temperature, as for example we take any particular organism, and any particular individual, and we say that that particular individual is at a resting stage, is actually resting, and she is present in a room temperature where the in a room where the temperature is 20 degrees centigrade, and there is moderate humidity. So internal body temperature, when we talk about the internal body temperature of that individual, his internal body temperature will be 37 degrees centigrade, and because of the lower temperature in that particular room, the heat will loss from the body of that individual, and the heat will dissipate into the external environment, because the external environment is at lower temperature. So when we look at the body of that particular individual, the cells of his body, they will start to produce heat to compensate the heat loss due to the change in the external environment. Mean the heat that has been dissipating from the body of that particular individual, that will be again regenerated by the cells of that individual to compensate that loss. So under these conditions, we can say that the body is not having net gain or loss of the heat. Mean the amount of the heat that is going to be lost from the body as a result of change in the external environment, that will be again generated by the cells of that particular individual, and at the end we will have no net gain or loss of the heat from that particular individual, and the temperature of that body will remain constant. So at this particular state, that body will be considered as in steady state. Steady state mean it is defined as the system in which a particular variable, for example in this case we are taking temperature as variable, it is not changing. When we have said that the temperature is set to 20 degrees centigrade, that is fixed at 20 degrees centigrade, but due to the difference of the temperature in the external environment as well as in the internal environment of our subject, of that particular individual, temperature is not changing, but the heat will energy in the form of the heat will start to loss from the body of that particular individual. So to maintain the internal environment constant, heat must be continuously generated within the body of that particular individual. So this is what we can call it as steady state, that and any particular individual will be considered in a steady state where there is any variable that is not changing, that individual will be considered in a steady state. So steady state, it is different from the equilibrium situation, uh, because in case of equilibrium situation, a particular variable is not changing, but no input of energy is required to maintain the constancy. So steady state temperature, for example, in our example, is steady state temperature is basically the set point. It can also be called as operating point of the thermoregulatory system. So this example, it is basically representing a generalization about the homeostasis, means stability of the internal environmental variable that can be achieved by the balancing of the inputs and outputs, mean amount of the heat that is being lost from the body of that specific individual, that will be compensated by the heat production within the body. So it means that any internal environmental variable, for example, in this case we are talking about the temperature, it can be stabilized by balancing of the inputs as well as outputs. For example, in this case, the body temperature, which is behaving as a variable, it will remain constant, because the heat production which is inside the body, it will be equal to the heat loss from the body in the form of output. If we further lower the temperature of that particular individual, initially we have said that our subject or that specific individual is in a room where the temperature is 20 degrees centigrade and there is moderate humidity. So in that case, that system will be considered as a steady state system in which there is no change in the variable, I mean the temperature is not changing. So now let me lower the temperature of the room rapidly. So, mean we lower the temperature to 5 degrees centigrade and we set the temperature there. As a result of this rapid decrease in the temperature, the loss of the heat from the body of our subject or that specific individual will be very rapid, and ultimately the balance will be disturbed between the heat gain and heat loss. So now at this specific temperature at 5 degrees centigrade, the temperature of that individual will start to decrease rapidly. It will start to fall now, and very rapidly. When the temperature start to fall in the body of our subject, now various homeostatic responses in the body, they will be operative, they will be activated to limit the fall in the temperature or to restrict the decrease in the temperature. Uh, we shall see those homeostatic responses in the upcoming slide. So this is the slide. This is a generalized diagram. Here you can see initially that initially the temperature is room temperature, and heat will be lost from the body because the room temperature is lower as compared to the body temperature. And if the room temperature is lower to 5 degrees centigrade, now as we have said that there will be rapid heat loss from the body, and body temperature will also start to fall. Initially, let's say that the body temperature was 37 degrees centigrade, and if our subject is in a room where the external temperature is decrease to 5 degrees centigrade, now the body temperature of that specific subject will also start to fall, and there will be various homeostatic control mechanism or the responses which will be operative in the body. Now the first homeostatic response in the body will be constriction of skin blood vessels. As you might have observed during the winter season, that when there is very low temperature, our blood vessels which are present on our skin, they are constricted. Similarly, Curling up of the hairs which are present on the skin, they curl up. They mean they will be in the upright position. And the third response, which will be produced by our body, that will be shivering. Our bodies will start shivering. So these are the homeostatic responses that will be operative in the body in response to the rapid heat loss from the body. So this is homeostatic control system. As I have said, that relatively constant body temperature, when the body temperature, when the room temperature decreases, it means that when the decrease room temperature, it will lead to the increased heat loss from the body, and ultimately decreased room temperature will result in increased heat loss from the body. And curling up mean it is a homeostatic response in the body to minimize that heat loss from the body. Similarly, when we okay. So these homeostatic control mechanism, they will be operative in the body. One of them is constriction of blood vessels. Other is curling up of hairs of the body, and the third mechanism will be shivering. So all these mechanism, they will operate in the body to compensate the heat loss from the body. For example, this constriction of the skin blood vessel, it will reduce further heat loss from the body. These two mechanisms, they will tend to further prevent the heat loss from the body, whereas shivering will start to generate the heat in the body. And all these mechanisms, their ultimate goal is to return the body temperature to the normal level, the temperature which was initially the temperature of the body. So all these homeostatic control mechanism, they will operate, they will respond, and they will tend to, these two mechanism, they will tend to reduce the heat loss from the body, whereas the shivering mechanism, it will be operative to produce the heat in the body. And overall, all these three homeostatic mechanism in the body, they will tend to compensate the heat loss that has occurred during the low temperature in the external environment. So first homeostatic response, as we have observed in the previous diagram, is that blood vessels to the skin, they will narrow, they will constrict. And when the blood vessels will constrict, it means the amount of the blood supply, or the amount of the warm blood flowing through the skin, that will be decreased there, and it will result in reduction of the heat loss from the skin portion. For example, at room temperature of 5 degrees centigrade, the blood vessel constriction cannot eliminate the extra heat loss from the skin. Mean this response alone, it cannot compensate the heat loss, or it cannot minimize, or it cannot eliminate the heat loss from the body. So to facilitate this homeostatic response mechanism in the body, the other homeostatic response which will be operative, which will be active in the body, is curling up of the hairs. Hair will curl up, and they will curl up in order to reduce the surface area of the skin available for heat loss. Mean when the hair will be in the curly shape, it will reduce the surface area, so that minimum amount of the heat will be lost from the skin. This also help a little bit, but excessive heat loss, still it will continue, and body temperature will continuously, it will keep falling. But the rate of that decrease in temperature, that will be a little bit slower down after activation of these two homeostatic response mechanism. So third mechanism, or any other homeostatic response that will be operative in the body, is that the person will have strong desire to put on more clothing. This is basically a voluntary behavior response. They are also very much crucial in the homeostatic event. But if the clothing is not available at that specific time, if the warm clothing is not available, then excessive heat loss cannot be prevented from the body. Now the only way of restoring the balance between the heat input and output is to increase the input. And this is what actually happens in the body, that our subject or that specific individual will start to shiver, and the chemical reaction which are responsible for the skeletal muscular contraction, they will constitute shivering. And when the shivering is there, a large amount of the heat will be produced in the body. All of you must have observed this phenomenon practically in your body as well, that when you are feeling when you are in very cold environment, as a result of homeostatic response, your body may start to shiver, and this homeostatic response is to compensate the heat loss that has occurred during the lower temperature, or at very cold condition. So here is another diagram in which you can see that how the heat loss uh, is compensated in the body by homeostatic control mechanism. So heat production as a result of this shivering mechanism, sometime it can even transiently, it can exceed the heat loss, and body temperature start to go back to towards the values existing before the room temperature was lower. Mean body temperature was initially at let's say that initially the body temperature was at 37 degrees centigrade, and after decreasing of the temperature of the external environment, the body temperature has also decreased, and let's say it has fallen down to 15 degrees centigrade or 20 degrees centigrade, and your body will start to lose heat from the body. But eventually, as a result of this heat production mechanism, which we have called it as shivering mechanism, now the body temperature will start to go back towards the normal value, and sometime even transiently it can even exceed the temperature which was initially temperature of the body before the change has occurred in the body. So ultimately, it will stabilize at a room temperature a bit below the original value. Mean transiently it can exceed, but normally the body temperature it cannot be set to that fixed point uh, before the change. Mean the body temperature which was initially, for example, let's say that the initial body temperature was 37 degrees centigrade, and after change, after decrease in external environment, or after decrease in temperature in the external environment, the body temperature it start to fall down, and it reaches to 10 degrees centigrade or 20 degrees centigrade. And when the homeostatic mechanism are operative in the body temperature again start to restore, but it cannot be reached to that fixed point. Mean it cannot be exactly, it cannot be again fixed to that is 7 degrees centigrade. It will be fixed at slightly bit value. For example, it can be set at 35 degrees centigrade, it can be set at 36 degrees centigrade, but we can't set it at exact 37 degrees centigrade. That's why we initially, in the very first slide, we have said that the homeostatic control system is to maintain the internal environment relatively constant. It means this is relative value. This is not the absolute value that after homeostasis our body temperature will again be fixed to 37 degrees centigrade. So that's why whenever we define the homeostasis, we always say that homeostatic control system, they operate to maintain the internal environment relatively constant. So heat input and heat output, in this case, they are both higher than their original values, but after all the homeostatic response mechanism which were operative in the body, the heat input and heat output, they will be again equal to each other. So here is another generalization in this diagram. You can see that changes in the internal body temperature when we have exposed the body to the lower external environment or lower temperature. So as long as the environmental perturbation persists, the homeostatic response, they do not return to regulate the variable completely to its original value. I mean, this is the deviation, and sometime it can be called as error signal. For example, here you can see that initial body temperature was 37 degrees centigrade. This system is called stable system, and it can also be called a set point. But after this homeostatic controls mechanism, when it is operative, the body temperature is less. This is at 36 degrees centigrade. It will be fixed at 36 degrees centigrade, and at this point it can also be called an error signal. Initially it was called as set point, but after the homeostatic control system or operative there, it cannot be fixed back to the original value. So it will be slightly lower than the original value, and this will be called as error signal. Okay, so thermoregulatory system, which we have described in all the previous slides, it is basically a negative feedback system, because in this system an increase or decrease in the variable being regulated, it will itself bring the response, and this response will move the variable in the direction that is opposite to that response. For example, in this particular case, the variable is moving towards the lower value. Mean body temperature will start to decrease when our body is exposed to the lower temperature of the external environment. So variable itself, so temperature which is variable in this case, so this lower temperature of the body or decrease in the body temperature, which we are saying that particular temperature is variable. So that variable will itself start response. Mean our body will start to respond to that decrease in temperature as a homeostatic response mechanism, and these responses will move the variable in the direction opposite. Mean initially the variable was from higher temperature to the lower temperature, and when the homeostatic mechanism, they are operative homeostatic responses, they are operative in the body. Now those responses, they will move the variable in the opposite direction. Now the variable or the temperature will again start to rise in the body. So that is an example of negative feedback mechanism or negative feedback system, in which the variable itself it induce the response in the body, and those response, they will move the variable in opposite direction of the initial direction. So that is why we can also call this as negative feedback system in the body. So decrease in body temperature, it will lead to the responses that tend to increase the body temperature. Mean it will move towards its original value. So negative feedback control system are most common homeostatic mechanism in the body, and there are also some positive feedback mechanism are also there. Positive feedback homeostatic control system, they are also operative in the body, in which any initial disturbance, it will set off response in the body, and those responses, those homeostatic responses, they will further move away that variable from the initial point. So they will further increase the disturbance. So this is what we can call it as positive feedback mechanism. So there are two types of the homeostatic feedback control system. One is positive feedback control system, and other is,
सर
yes.
सर पॉजिटिव को फिर से एक्सप्लेन कर दें.
पॉजिटिव का मतलब ये है कि कोई जो चेंज हुई है, फॉर एग्जांपल आपका बॉडी टेम्परेचर लो होना शुरू हो गया, तो आपका होम्योस्टेसिस उसी डायरेक्शन में ऑपरेटिव होगा, और वो उसको फर्दर अगर लोअर डाउन कर दे, दिस इज एन एग्जांपल ऑफ पॉजिटिव फीडबैक और पॉजिटिव होम्योस्टेटिक कंट्रोल सिस्टम। और नेगेटिव में क्या है कि जो आपकी बॉडी में जो है वो चेंज आई है, आपका वेरिएबल जो चेंज हुआ है, तो आपका होम्योस्टेसिस उसकी उसकी अपोजिट डायरेक्शन में ऑपरेटिव होगा। मीन योर होम्योस्टेटिक रिस्पॉन्स विल टेंड टू मूव दैट वेरिएबल इनटू द अपोजिट डायरेक्शन। टेम्परेचर में लोअर होगा तो आपका होम्योस्टेटिक कंट्रोल मैकेनिज्म उसको फर्दर जो है वो यानी उसको इंक्रीज करना शुरू कर देगा। सो दिस इज द difference between the positive feedback and negative feedback mechanism. So positive feedback mechanism ultimately it will not favor the stability, and it sometime it can displace a system away from its normal set point. Mean initially the body temperature is 37 degrees centigrade and your body temperature has decreased as a result of change in the external temperature. So your positive feedback mechanism will further decrease the body temperature. So it will move a system, or it will displace a system away from the set point. Several important positive feedback relationship there are the mechanism they are operative in the body. Contraction of the uterus during the labor, this is one example of the positive feedback control system in the body. Similarly, uh, not only the thermoregulatory negative feedback mechanism, uh, it not only bring back the temperature of that specific individual to its normal value, uh, it also shows another generalization about the homeostasis, that homeostatic control system uh, do not maintain complete consistency or constancy of the internal environment. As I have already told you, that this system it tends to minimize the changes in the internal environment as a result of changes in the external environment, but it cannot keep the internal environment 100% constant. So this is a generalization about the homeostasis, that homeostasis it actually does not maintain the complete constancy of the internal environment as a result of changes in the external environment, but it can minimize those changes. So that's why homeostatic control system, it maintain the internal environment relatively stable. So this is one example. Similarly, if the initiating event, for example, exposure to cold, as in our previous example we have discussed, so if your body is continuously exposed to the event or initiating event, for example cold, so changes in the regulated variable, for example the decrease in the body temperature, they will persist there, and they will persist to act as a signal. These changes will produce a signal in our body, and that signal will initiate the homeostatic response of our body. So it means that this persisting signal is, sometime it can also be called as error signal. Mean when our body is exposed to lower temperature for a longer period of the time, so your body temperature will start to decrease as a result of the change in the external environment, and this decrease in temperature, or this heat loss from your body, it will behave as an error signal. It will be read by our body, by our integrating system as error signal. And when this error signal is read by our body, it is perceived by our body, our homeostatic control system or control responses, they will be activated in the body. So external temperature, it will go back to the original value. The homeostatic system will be able to restore the body temperature completely back to its original. So only this error signal, or this error signal can be set back to the reset point when the external temperature is again completely, it is moved back to its original value. For example, the external temperature initially was 20 degrees centigrade, and after certain interval of the time, and that at that 20 degrees centigrade, our internal body temperature was 37 degrees centigrade. And when there is decrease in the external or the room temperature, for example the room temperature uh, was decreased to 5 degrees centigrade, there will be rapid heat loss from the body, and the body temperature will also decrease there. So this body temperature can be moved back to 37 degrees centigrade only if the external room temperature will also be restored to the 20 degrees centigrade. So in that particular case, the body temperature can be set back to its normal value. So control system, it does not overcompensate, mean it cannot move the system beyond the set point. For example, we have said that sometime transiently heat production in the body as a result of shivering can exceed the heat loss from the body, but this is very rare event. It is very less likely to occur in the body. Normally a control system, it cannot set a system beyond the set point, mean our control system or our homeostatic control system cannot increase the body temperature more than 37 degrees centigrade in certain cases. So when our set point or our control system will try to reset beyond the set point, mean it will increase the body temperature more than 37 degrees centigrade. Let's say it increase the body temperature to 38 or 39 degrees centigrade, it will produce another type of the physiological imbalance. So that's why it means that error signal is another generalization about homeostasis, that if there is any variation in the external environment, that variation will produce a change, and that change will be read as the error signal by our body, and our control system or our homeostatic response mechanism will reset that change to the set point, and it cannot move that change beyond the set point, mean it cannot increase the temperature more than 37 degrees centigrade. So it means a regulatory variable sometime it cannot be assigned as a signal or the normal value, but most of the time it has narrow range of the normal value, mean it is depending upon the magnitude of the changes in the external condition and the sensitivity of the responding homeostatic system. For example, we can say that all the individual, their body temperature as a result of decrease in the external environment, that cannot be set back to a fixed value. It is dependent upon the magnitude of the change. For example, कितनी हीट जो है वो बॉडी से लॉस हुई है, कितने टेम्परेचर डिक्रीज हुआ है, और बाहर एक्सटर्नल टेम्परेचर कितना डिक्रीज हुआ है, और दूसरी चीज़ ये है कि उस बॉडी का होम्योस्टेटिक रिस्पांस जो मैकेनिज्म है वो कितना एक्टिव है, वो कितना जल्दी जो है वो रिस्पॉन्ड कर रहा है to the change in the external environment. So there is narrow range. For example, one individual, that body temperature of one individual can be set back, for example, to 35, the other may be set back to 30, 36, and some other, the body temperature of some other individual, that may be set back to 34 degrees centigrade. So there is narrow range, mean 1 या 2 डिग्री का डिफरेंस हो सकता है. This is what we can call it as narrow range. तो हर जो इंडिविजुअल है as a result of change in the external environment, उसका जो homeostatic control mechanism है, it cannot maintain the internal temperature at a fixed value in all the individual. They will have the different value of the internal body temperature, but that value will be within a narrow range, mean there will be difference of 1 or 2 degree centigrade maximum, उससे ज़्यादा जो है वो difference नहीं हो सकता. तो इसमें और दूसरी जो important चीज़ है, second important generalization is about the how actively or how quickly our body respond to that change. हर इंडिविजुअल की बॉडी ज़रूरी नहीं है कि उस तरह से रिस्पॉन्ड करे. आपने देखा होगा बाद लोगों को ज़्यादा सर्दी लगती है, बाज़ को कम लगती है. सिमिलरली बाद लोगों को गर्मी ज़्यादा लगती है, बाज़ को कम लगती है. इसका मतलब ये है कि उनका जो बॉडी का रिस्पॉन्स है, जो रिसेप्टर्स हैं उनके बॉडी के, वो डिफरेंट वे में जो है वो रिस्पॉन्स कर रहे हैं. ठीक है, तो इसका मतलब ये है कि स्मॉलर error signal, it need to derive the system, the narrower is the range, मीन जितनी कम चेंज आएगी, जितना स्मॉल एरर सिग्नल होगा, तो फिर रेंज भी उतना नैरो होगी. ये 0.5 डिग्री की हो सकती है, ये उससे भी कम हो सकती है, लेकिन जितना लार्जर जो है वो एरर सिग्नल होगा, तो फिर जो है उसमें डिस्टर्बेंस भी ज़्यादा होगी, और फिर जो मुख्तलिफ इंडिविजुअल में जो मार्जिन होगा डिफरेंस का, वो भी क्या होगा, वो थोड़ा सा जो है वो ज़्यादा होगा. ठीक है, फॉर एग्जांपल इफ वी लुक एट द टेम्परेचर रेगुलेटिंग सिस्टम ऑफ द बॉडी, they are extremely sensitive to the body temperature varies by only 1 degree centigrade, even in the face of the marked changes in the external environment or heat production during the exercise. यानी ये कहते हैं कि अगर बाहर जो है वो बहुत ज़्यादा टेम्परेचर में जो है वो फ़र्क हो और या हीट भी प्रोड्यूस हो रही हो एज ए रिजल्ट ऑफ एक्सरसाइज इन द बॉडी, तो इंटरनल बॉडी टेम्परेचर में सिर्फ 1 डिग्री का जो है वो फ़र्क आता है। ठीक है ना। ये आप देखेंगे 20 डिग्री सेंटीग्रेड एक्सटर्नल एनवायरनमेंट है, तो आपका इंटरनल एनवायरनमेंट 20 डिग्री सेंटीग्रेड पे भी मोर और लेस 37 ही रहेगा। लेकिन अगर आपका बॉडी टेम्परेचर जो है वो 20 से लेट्स सपोज कि 15 डिग्री पे आ गया है, तो हो सकता है आपका इंटरनल बॉडी टेम्परेचर में सिर्फ 1 डिग्री का फ़र्क आए, यानी 1। तो इसका मतलब यह है कि जितना जो है वो ड्रास्टिक या जितना ज़्यादा चेंज एक्सटर्नल एनवायरनमेंट में होगा, उतना ही आपकी बॉडी जो है वो फिर वो जो है वो उतना ही उसमें जो है वो एरर सिग्नल भी जो है वो ज़्यादा होगा। ठीक है। तो यानी अगर उसमें जो है वो वेरिएशन कम है तो मार्जिन ऑफ एरर भी बहुत जो है वो कम हो जाएगा, आपकी इंटरनल बॉडी टेम्परेचर में जो वेरिएशन है वो भी जो है वो कम हो जाएंगी। ठीक है। तो इस तरह से बाज़ औक़ात अगर लार्ज डिस्टर्बेंस है इंटरनल एनवायरनमेंट में, एक्सटर्नल एनवायरनमेंट में, तो उसकी वजह से आपका जो वेरिएबल है वो सेट पॉइंट से फिर ज़्यादा जो है वो डिस्प्लेस हो जाता है। ठीक है। सो सेट पॉइंट ऑफ मेनी रेगुलेटेड वेरिएबल, दे कैन बी फिजियोलॉजिकली अल्टर्ड और रीसेट। ठीक है ना। For example, the values that the homeostatic control system was trying to keep relatively constant, they can be altered. Sometime ये जो set point है इसको आप जो है वो reset भी कर सकते हैं। For example, normally हम ये कहते हैं कि our body temperature is 37 degree centigrade. But if any person is having an infection in the body, तो that set point can be reset to 100 degree centigrade. हम ये कहते हैं जी किसी को 100 का जो है वो बुखार है, तो इसका मतलब ये होगा कि उसका बॉडी टेम्परेचर उस वक्त कितना है, 100 डिग्री सेंटीग्रेड है। सो दी सेट पॉइंट समटाइम दे कैन बी रीसेट। और ये रीसेट भी किस लिए होते हैं, दिस इज द नेचुरल मैकेनिज्म इन द बॉडी। ये हमेशा याद रखें कि फीवर इज इटसेल्फ नॉट ए डिजीज और डिसऑर्डर। फीवर जो है, अगर आपका बॉडी टेम्परेचर ज़्यादा है, इट मीन्स योर बॉडी इज हैविंग एनी इन्फेक्शन टू कोप और टू प्रोड्यूस द रिस्पॉन्स अगेंस्ट दैट बॉडी इन्फेक्शन। आपका बॉडी टेम्परेचर इसलिए इंक्रीज कर जाता है ताकि आपकी बॉडी के अंदर कोई भी जो जर्म्स हैं, कोई जो बैक्टीरिया हैं या कोई भी जो माइक्रो ऑर्गेनिज्म है, इन्फेक्शियस एजेंट है, वो सर्वाइव ना कर सके बॉडी इतने ज़्यादा हाई टेम्परेचर पे। सो द सेट पॉइंट दे कैन आल्सो बी रीसेट इन सर्टेन केसेस। फॉर एग्जांपल, इन केस ऑफ फीवर आई हैव टोल्ड यू दैट body temperature may increases up to 100 degrees centigrade. And why this increase in temperature is there, this is basically in response to any infection. So that's how you can reset the set point. For example, आप अपने घर के अंदर आप एसी जो है उसको जो है वो सेट कर रहे हैं या अपने थर्मोस्टेट को सेट कर रहे हैं, तो आप उसका टेम्परेचर जो है वो 20 डिग्री से 15 में भी ला सकते हैं। 20 से जो है वो अगर सर्दी है तो आप उसको 37 पे भी ला सकते हैं। तो इसी तरह से नेचुरली our body set point they can be reset, and that are natural mechanism that can be operated in the body. ठीक है। So homeostatic control system which are regulating the body temperature, still they are functioning during a fever, but they are maintaining the body temperature at higher level. मीन वो भी तो एक चेंज है ना कि आपका इंटरनल एनवायरनमेंट जो है वो आप इंटरनल टेम्परेचर 100 डिग्री सेंटीग्रेड पे चला गया, तो अब होम्योस्टेसिस को उसको कंट्रोल करना चाहिए, दोबारा 37 पे लाना चाहिए। बट होम्योस्टेटिक कंट्रोल सिस्टम इज ऑपरेटिव इन दैट केस आल्सो। यस प्लीज।
सर ये होगा जो हम कहते हैं कि ये 100 पे चला गया है, ये
यस
फ़ारेनहाइट है?
यस प्लीज। नहीं,
सर आप
फ़ारेनहाइट में तो नहीं होगा। फ़ारेनहाइट तो आप देखिए ना 32 या 33, वो 98 या इसके अराउंड जो है ना वो उस पे होता है फ़ारेनहाइट पे, आई गेस। इज इट? आप इसको चेक कर सकते हैं
सर
कि यस।
मेरे ख्याल से जब डिग्री में हम कहते हैं चेंज हो रहा है तो ये 38 तक जाता है, इससे अब नहीं जा सकता।
हाउ इज इट इज पॉसिबल? तो फिर हम जो कहते हैं कि 100 डिग्री का बुखार है, तो वो कैसे है?
सर
यस प्लीज।
सर आई थिंक वो फ़ारेनहाइट में करते हैं क्योंकि वो 90.6 होता है, 98.6 इज इक्वल टू
क्या?
37।
वही मैं कह रहा हूँ ना। तो जब आपको 100 डिग्री का बुखार है तो फिर उन्हें कैसे पता चलता है कि आपका टेम्परेचर 100 है? जी प्लीज।
सर उसके अंदर अगर 37 से 38 होता है तो इट मीन 98.6 से वो 100 तक जाता होगा फिर फ़ारेनहाइट में। और इससे अगर अबव हो जाए तो इट मीन 39 शायद।
बॉडी टेम्परेचर,
यस सर, फ़ारेनहाइट के अंदर।
ओके, इट मीन यू आर सेइंग कि वो मेजर करते हैं किस में? फ़ारेनहाइट में। फ़ारेनहाइट में आपका 100 होना चाहिए, इट मीन्स कि उसको बुखार है।
यस सर।
ओके, बट इन दिस केस अगर फिर भी आप देखें तो ज़ाहिर है चेंज तो आ रही है ना टेम्परेचर में।
यस सर, टेम्परेचर ये 38 होगा फिर।
37 तो नहीं है ना, दैट विल बी 39 और इवन 40, या हम कहते हैं 38, लेट्स सपोज 38 भी कह रहे हैं, तो होम्योस्टेसिस को तो उसको दोबारा 37 में करना चाहिए ना।
यस सर।
क्या ख्याल है? ओके
सर वो
जी, आप बोले ना प्लीज, यू आर फ्री टू स्पीक,
जी सर,
यू कैन
जो टेम्परेचर
यू
बहुत
कैन
ज्यादा
से
तो इंक्रीज नहीं हो, थर्मामीटर में जो मर्करी डाली होती है वो सर एक स्लाइड से थोड़ी सी चेंजिंग भी होगी तो उसको बहुत ज्यादा इंक्रीज करके तो दिखाता है रिजल्ट।
ओके, बट स्टिल देयर इज चेंज इन द बॉडी टेम्परेचर। 37 तो नहीं है ना, सेट पॉइंट से क्या हो गया, रीसेट तो हो गया ना, कि नहीं हुआ?
जी सर होगी।
ठीक है ना। सो दैट मैकेनिज्म वो इसलिए है कि आपकी जो डिफेंस, दिस इज बेसिकली द इम्यून रिस्पांस मैकेनिज्म इन द बॉडी, और ये आपका सेट पॉइंट रीसेट इसलिए होता है ताकि कोई भी जो फॉरेन पैथोजेनिक ऑर्गेनिज्म है आपकी बॉडी के अंदर जो है वो सर्वाइव ना कर सकें। सो होम्योस्टैटिक कंट्रोल सिस्टम इज आल्सो ऑपरेटिव इन दैट केस, बट योर होम्योस्टैटिक कंट्रोल सिस्टम विल मेंटेन द टेम्परेचर एट हायर वैल्यूज, even it can maintain at 38 even higher than that also। ठीक है, तो इसका मतलब ये हुआ कि सेट पॉइंट जो है हम इसको जो है वो क्या कर सकते हैं, रीसेट कर सकते हैं एज एन एडाप्टेशन। ठीक है ना, इन दैट केस, इन केस ऑफ फीवर, इसलिए कि जब आप इसको जो है वो इंक्रीज करेंगे तो ये आपका ऑटो इम्यून नेचुरल मैकेनिज्म है बॉडी के अंदर, ऑटो इम्यून रिस्पॉन्सेस, हो दैट your body temperature pathogenic organism in the body they cannot survive। ठीक है ना, तो उनको उनकी जो है वो ग्रोथ को रोकने के लिए आपका बॉडी टेम्परेचर जो है वो क्या हो जाता है, वो इंक्रीज हो जाता है। ठीक है, सिमिलरली सम टाइम प्लाज्मा आयरन कंसंट्रेशन जो है इन्फेक्शन के दौरान वो भी जो है वो क्या हो जाती है, डिक्रीज हो जाती है। ठीक है, तो इसका मतलब ये हुआ until recently it was assumed that this decrease is symptom caused by the infectious organism and it should be treated with iron supplement, but the fact is on the other side, इसमें कहते हैं कि जब आयरन बहुत सारे इन्फेक्शियस डिजीजेज में या बहुत सारे इन्फेक्शन में आपकी बॉडी में आयरन जो है वो कम हो जाता है, तो आयरन का जो ये जो कमी है, द डिक्रीज इन द आयरन इज ब्रॉट अबाउट बाय द बॉडीज डिफेंस मैकेनिज्म। ठीक है ना, और दिस डिफेंस मैकेनिज्म टू डिप्राइव द इन्फेक्शियस ऑर्गेनिज्म ऑफ द आयरन, यानी ज़ाहिर है अगर आयरन उधर सप्लीमेंट होगा तो इन्फेक्शियस ऑर्गेनिज्म दे कैन रेप्लिकेट। सो इन सर्टेन केसेस अगर किसी इंडिविजुअल में जो है वो कोई इन्फेक्शन हो गई है और उसमें आयरन की डेफिशिएंसी है, अगर आप उसको आयरन सप्लीमेंट के साथ ट्रीट करना शुरू कर देंगे तो दैट कैन इवन वर्सन द कंडीशन। तो उस केस में फिर क्या होगा, क्योंकि वो उसमें नेचुरल ऑटो इम्यून और द डिफेंसिव मैकेनिज्म है बॉडी के अंदर टू डिप्राइव द माइक्रो ऑर्गेनिज्म और द इन्फेक्शियस ऑर्गेनिज्म फ्रॉम द सप्लाई ऑफ द आयरन। ठीक है ना, और जब आयरन की सप्लाई उनकी होगी तो उनमें रेप्लिकेशन ज़्यादा हो जाएगी। ठीक है, सो इट मीन्स दैट आयरन रिप्लेसमेंट in those cases can even make the illness much worse। So it means that we should have to distinguish between those deviation of homeostatic control variable that are part of the disease and those there those through resetting, they are part of the body defense against the disease. So we will have to differentiate between those two deviation. One deviation is homeostatic deviation. For example, rise in body temperature from 37 to 38 degree centigrade or 39 degree centigrade, इसको हम दो पैराए में ले सकते हैं. इसको हमने डिफरेंशिएट करना है कि वेदर दिस इज होम्योस्टैटिक डिस्टर्बेंस इन द बॉडी और दिस इज डिफेंस और ऑटो इम्यून रिस्पॉन्स बाय द बॉडी. ठीक है ना. इन बोथ ऑफ द केसेस द सेट पॉइंट कैन बी इज रीसेटेड एक्चुअली. ठीक है ना. यानी दोनों केसेस में इसमें सेट पॉइंट आपका क्या हुआ, रीसेट हुआ है. ठीक है. अगर तो वो होम्योस्टैटिक जो है वो मैकेनिज्म है या उसको ऑपरेटिव होना है, तो उस केस में तो नॉर्मली क्या होगा कि आपके बॉडी जो है वो रिस्पांस प्रोड्यूस करेगी, यू विल स्टार्ट टू स्वेट और आपकी जो है वो डायलेशन स्टार्ट हो जाएगी ब्लड वेसल्स में एंड हीट टेंड टू लॉस फ्रॉम योर बॉडी. ठीक है ना. ये तो आ गया होम्योस्टैटिक रिस्पांस. लेकिन आप उसमें देखते हैं कि अगर ये जो ऑटो इम्यून रिस्पांस बॉडी का, तो आपने देखा होगा कि आपको फीवर के दौरान भी बाज़ वक़्त आपको सर्दी लगती है. ठीक है ना. आपने ऑब्जर्व किया होगा कि आपको बुखार है तो आपको फर्दर जो है वो सर्दी फील हो रही है, तो इसका मतलब ये हुआ कि दैट इज ऑटो इम्यून रिस्पांस और द डिफेंसिव मैकेनिज्म व्हिच इज ऑपरेटिव इन द बॉडी. सो that's how we can differentiate between these two deviations, that whether the set point should be reset by the homeostatic control system or this set point is actually reset by the immune or the defensive mechanism of the body. ठीक है. उसका मतलब ये जो दो हमने एग्जांपल पढ़ी हैं, one is of the fever and the iron concentration, they can be in those generalization we can say that the set point are reset only in response to the external stimuli such as the bacteria. ठीक है. यानी इसमें मोस्टली हम जो है वो क्या कर सकते हैं, सेट पॉइंट को जो है वो हम जो है वो सेट कर सकते हैं. बट another important point is that sometime many regulated variables they can also be reset on rhythmical basis every day. For example, if we talk about the body temperature, the body temperature is higher during the day. Another important point about the set point, the set point can be reset against pathogen against any type of the infection, and set point can also be reset on rhythmical basis as well. Mean these variable they can be regulated on rhythmical basis as well. For example, if we talk about the body temperature, it can be higher during the day as compared to the night. So resetting of the set point, it is basically an adaptation or it is an adaptive response in some cases, but it sometime it also shows or it also represent the clashing demands of the regulatory system. For example, फीवर की मैंने एग्जांपल दे दी कि अब इसमें आपके होम्योस्टेसिस में और आपका जो ऑटो इम्यून सिस्टम है उनमें क्लैशिंग डिमांड है. होम्योस्टेसिस टेंड टू डिक्रीज द बॉडी टेम्परेचर फ्रॉम 38 or 39 degree centigrade, but your auto immune system is resetting or it is increasing the body temperature. So sometimes it is also producing a sort of clash between different regulatory system which are present in our body. ठीक है. तो इसका मतलब ये हुआ कि हम किसी भी चीज़ को, किसी भी वैल्यू को, किसी भी वेरिएबल को इवन विद द होम्योस्टैटिक कंट्रोल सिस्टम भी हम इसको जो है वो we can't set any variable at constant value even with the help of homeostatic control system. ठीक है ना. For example, हमने body temperature की बात की कि body temperature was kept relatively constant, but only because large change in the skin blood flow and skeletal muscle contraction they were brought about by the homeostatic control system. ठीक है ना. उसमें रिलेटिवली तो बॉडी टेम्परेचर कांस्टेंट रह सकता है और एज ए रिजल्ट ऑफ होम्योस्टैटिक जो रिस्पांस मैकेनिज्म है, कंट्रैक्शन ऑफ द ब्लड वेसल है एंड सिमिलरली कंस्ट्रिक्शन ऑफ द ब्लड वेसल है एंड डिक्रीजिंग द ब्लड फ्लो इन द स्किन, ये these homeostatic responses they can maintain the body temperature at relatively constant value, but absolute constant value it is impossible to achieve. ठीक है. तो इसका मतलब ये हुआ कि इंटरनल इन्वायरमेंट जो है इनकी जितनी भी there are many properties of the internal environment, they are interrelated. So it means sometime we can keep one property relatively constant by moving other further from there usual set point. So it is what we can call it as clashing demands. So we can also say that multiple system they are also controlling the single parameter. For example, if we look at the बॉडी टेम्परेचर की ही अगर हम मिसाल लें तो उसमें आपने देखा आपकी स्किन भी काम कर रही है, आपके जो है वो स्केलेटल सिस्टम भी काम कर रहा है, सिमिलरली आपका जो सर्कुलेटरी सिस्टम है यानी ब्लड फ्लो भी डिक्रीज हो जाता है. सो इट मीन्स दैट रेगुलर इवन ए सिंगल वेरिएबल दैट इज कंट्रोल्ड बाय द मल्टीपल सिस्टम विच इज ऑपरेटिंग इन द बॉडी. ठीक है, यहाँ पर जो एडेप्टिव वैल्यू है this adaptive value is actually providing the fine tuning, and it also permit the regulation. uh, मीन व्हेन देयर इज रिडेंडेंसी का मतलब ये है कि एक वेरिएबल को अगर एक से ज़्यादा सिस्टम जो है वो कंट्रोल कर रहे हैं, तो अगर एक सिस्टम में कोई अबनॉर्मलिटी है, कोई प्रॉब्लम है, तो आपका दूसरा सिस्टम जो है वो एट द सेम टाइम उसको क्या कर सकता है, उसको जो है वो सेट कर सकते हैं. ठीक है, तो यहाँ पर अगर आप देखें देयर आर सम अदर जनरलाइजेशन अबाउट द होम्योस्टेसिस. द स्टेबिलिटी ऑफ द इंटरनल एनवायरनमेंट इज अचीव्ड बाय बैलेंसिंग इनपुट एंड आउटपुट, and it is not the absolute magnitude of the input and output that matter but the balance between them. Similarly in negative feedback system मैंने आपको बताया कि कोई भी जो रिस्पांस है ये वेरिएबल को उसकी अपोजिट डायरेक्शन में मूव करेगा टूवर्ड्स द ओरिजिनल चेंज. यानी ओरिजिनल चेंज ये थी कि डिक्रीज इन टेम्परेचर था, इन केस ऑफ नेगेटिव फीडबैक सिस्टम टेम्परेचर दोबारा क्या होगा, इंक्रीज होगा, इट इज बैक टूवर्ड्स द इनिशियल वैल्यू विच इज सेट पॉइंट. ठीक है, एंड होम्योस्टैटिक कंट्रोल सिस्टम दे कैन नॉट मेंटेन द कंप्लीट कॉन्स्टेंसी ऑफ एन गिवन फीचर ऑफ इंटरनल एनवायरनमेंट. फॉर एग्जांपल टेम्परेचर की हमने बात की कि जो रेगुलेटेड वेरिएबल है, फॉर एग्जांपल टेम्परेचर है, इट विल हैव मोर और लेस नैरो वैल्यू ऑफ नॉर्मल वैल्यू, नैरो रेंज ऑफ नॉर्मल वैल्यू. मीन ये 35 भी हो सकता है, 36 हो सकता है, 38 हो सकता है. रेंज विल बी नैरो बट स्टिल जो है उसमें थोड़ा बहुत डिफरेंस आ सकता है. द सेट पॉइंट कैन बी also regulated and sometime it can be reset. It can be physiologically it can be raised or lowered. ठीक है, और another important generalization about homeostasis is that it is not possible for everything to maintain relatively constant by homeostatic control system. So it means that constancy of certain variable may be altered to maintain other variable at relatively constant value. ठीक है ना, यानी at the expense of one variable the other variable may be set. यानी ज़रूरी नहीं है कि आप एक ही टाइम में सारे जो वेरिएबल हैं उनको जो है वो कांस्टेंट रख सकें बॉडी के अंदर. ठीक है, तो इसमें another important regulation is feed forward regulation. Feed forward regulation, this is another type of the regulatory process which is operative in the body, which is operative with the negative feedback system. So here let's take the example of feed forward regulation. The temperature sensitive nerve cells which are present in our body, they basically trigger the negative feedback regulation of the body temperature when the body temperature begins to fall, and these temperature sensitive nerve cells, they are present inside the body. So these temperature sensitive nerve cells they are in the skin, and these cells they basically monitor the change in the environment. We can also call them as the receptor. We will discuss the receptor in the upcoming lecture. So when outside temperature falls, for example in our previous example we have said that our subject is in a room where the temperature is 20 degrees centigrade, and when the temperature was lower to 5 degrees centigrade, it means the external temperature that falls rapidly. So nerve cells, they will detect the change in the external environment. So this is the important function of these nerve cells, that those nerve cells, they will act as receptor. They will detect the change in the external environment, and they relay those information to integrating center, which is the brain. And your brain will send out the signals to the blood vessels and muscles. Mean your brain, which is an integrating center, it will relay those information to the effector, and effector in this case are muscles in or your blood vessels, and those effector will ultimately produce the response in the body against the change in the external environment. Mean the temperature in the external environment that has decreased, so that decrease or that change in temperature is is received by the receptors, which are called nerve cells. Those nerve cells, they will send the information to the brain, and brain, after integration of those information, the brain will relay those information. It will send the information to the effectors in the body, and effector in this case are muscles and blood vessels. They will produce their response. So this is what we can call it as uh, feed forward regulation. So in this manner, compensatory thermoregulatory response are activated before the external temperature that start to change, or that start to cause the change in the internal body temperature. This is feed forward regulation. It basically anticipates the changes in a regulated variable such as internal body temperature. It will improve the speed of the body homeostatic responses. So the important function of the feed forward regulation is that it anticipate, or it actually sense the changes in the external environment. As a result of those changes in the external environment, it speed up the regulatory mechanism or homeostatic regulatory mechanism in the body to cope with that change in the external environment and minimize the fluctuation. It will minimize, this feed forward regulation will minimize the fluctuation in the level of the variable being regulated. So it means it will this feed forward regulation will reduce the deviation from the set point. Mean when the feed forward regulation is feed forward regulatory mechanism is operative there, your body internal body temperature, it will deviate at a very lower level, at a very narrow margin from the set point. For example, feed forward control utilizes a external environmental detectors, and most feed forward control is result of a different phenomenon which is called learning. So although it is uh, it is inherent property of the body, but after repeated exposure to the change in the external environment, the feed forward regulatory mechanism will be more efficient. This is what we can call it as learning. So it means the time and again when this change is there in the external environment and our body is exposed to that change, our feed forward regulatory mechanism will be more efficient in detecting that change and in speeding up the homeostatic control system in our body. The first time they occur early in the life, the external environment changes, they will cause the relatively large changes in the internal environmental factor. Mean that deviation in the temperature that could be at larger scale. Mean it can be uh, higher values deviation. But when the body is exposed to the external environment that is changing uh, time and again, so it means that our feed forward regulatory system will be more proficient, more active in that case. So it means the system has learned now, the system has learned to anticipate them and resist them more effectively. So this is we can say that our feed forward regulation, although it is inherent property, but it will be more effective as a result of learning mechanism. A similar form of this learning is to ride a bicycle with with minimal sign. Learning of this type probably explain many situation. Mean आप initially अगर आप देखें तो आप बाइसाइकिल को जब आप राइड करेंगे तो आप जो है वो आपको बहुत ज़्यादा जो है वो एफर्ट करनी पड़ेगी. But when you are trying time and again, तो अल्टीमेटली आप एज ए रिजल्ट ऑफ लर्निंग मैकेनिज्म आप इतने एक्सपर्ट हो जाएंगे कि आप जो है वो एक्सटर्नल इन्वायरमेंट में बहुत ज़्यादा चेंजेस भी होंगे तो आपके इंटरनल इन्वायरमेंट में जो है वो कम चेंजेस जो है वो आएंगे. ठीक है. सो दैट इज ऑल अबाउट द homeostatic control mechanism. Any question? If you have any question, you can ask, please. Ji, if you have any question, you can ask. कोई क्वेश्चन नहीं समझ आ गए सब लोगों को? Okay, Ji. Thank you very much. Please stay connected. so that I could upload your